Somewhere over the southern plains, a dome of high pressure has parked itself in the sky and it is refusing to move. Around its edges, one disturbance after another is being flung outward like stones from a slingshot, and every single one of them is aimed at the same stretch of America. Meteorologists have a name for this. They call it a ring of fire. And in the middle of August, in a month that is supposed to be dominated by heat domes and quiet, sticky afternoons, this pattern has come roaring back to life for the first time in years. What is unfolding across the Midwest and the Ohio Valley right now is not a single storm. It is a chain reaction. It is a week-long, possibly 2-week-long parade of violent thunderstorms, one wave crashing in behind the last. And forecasters are warning that this kind of setup has not gripped the region with this much persistence in 4 or 5 years. Ring of fire patterns are not new to meteorology. They tend to show up most often in mid to late summer when a large, dominant area of high pressure builds over the central United States and effectively takes control of the jet stream around it. The name itself comes from the shape the storm activity traces on a map over several days, a rough loop or arc of thunderstorm clusters curling around the northern and eastern flank of that high pressure dome, almost like flames licking around the edge of a burning ring. Forecasters have seen versions of this setup before during past summers when a heat dome parked itself over Texas or Oklahoma and pushed disturbance after disturbance up and over the northern plains and into the Midwest. But what makes any individual ring of fire event dangerous is never really the concept itself. It's how long the high pressure system refuses to budge and how many disturbances get funneled around it before it finally breaks down. To understand why this matters, you have to understand what a normal August storm looks like, and then you have to understand why this one refuses to follow the script. A typical summer severe weather day in the Midwest arrives, does its damage, and leaves. The atmosphere resets. People clean up, the sun comes back out, and life continues. But this pattern is different because the high pressure system sitting over the southern plains is acting like a wall, and every disturbance moving through the upper atmosphere is being deflected around it in a curved, repeating track. That track runs directly over the Midwest, through the Ohio Valley, and into the Appalachians. Storm after storm is riding that same invisible rail, hitting some of the same towns and cities again and again, sometimes within hours of each other. Meteorologist Max Schuster, who tracks severe weather patterns for a living, put it in blunt terms. Over a 3-day stretch beginning this week, he said, multiple disturbances and strong atmospheric instability would fuel round after round of severe thunderstorms stretching from the Midwest into the Ohio Valley and the Appalachians. That alone would be notable in any given August. What makes it different this time is the scale of the risk zone and how many separate hazards are stacking on top of each other at once. On the first day of this event, a broad, slight risk of severe weather stretched from around Chicago and Peoria through Kentucky and into Virginia. That is a corridor covering multiple states and tens of millions of people. Around that zone, an even wider marginal risk area extended from the northern plains all the way to Washington, D.C., meaning a huge share of the country's population had at least some chance of seeing dangerous weather before the day was over. The primary concern, according to forecasters, was not tornadoes, although tornadoes could not be ruled out. It was something that tends to get less attention in headlines but can be just as destructive. Straight-line winds. Straight-line winds sound almost harmless compared to a tornado, but they are not. Forecasters were warning that some of these storms could produce gusts between 80 and 85 miles an hour during the middle of the day, embedded within long, fast-moving lines of thunderstorms. An 85-mile-an-hour wind gust is strong enough to snap mature trees, tear roofing material off houses, flip unanchored trailers, and knock out power to entire counties in a matter of minutes. Unlike a tornado, which carves a narrow, unpredictable path, a line of severe straight-line winds can flatten trees and damage structures across a corridor tens of miles wide and hundreds of miles long. Schuster said he expected this to be primarily a straight-line wind threat, but he was also careful to note that tornadoes could become embedded directly within the line itself, hidden inside the broader storm structure, striking with almost no additional warning. Meteorologists sometimes refer to this hidden tornado risk as a quasi-linear convective system, embedding a mesovortex, a technical term for what is really a small, tight spin of rotation buried inside a larger squall line. These embedded circulations can be harder to detect on radar than a classic supercell's rotation, and they frequently develop and dissipate within minutes, giving warning forecasters a narrower window to issue a tornado warning before the circulation has already touched down or moved on. That distinction between an isolated tornado producing supercell and a tornado hidden inside a fast-moving line matters more than people realize. The supercell announces itself. It is a single, rotating storm that radar operators and storm chasers can track for hours, giving communities time to prepare. A tornado embedded in a line is a different animal entirely. It can spin up quickly, often with less lead time, inside a chaotic wall of wind and rain that is already producing hazardous conditions on its own. For people on the ground, that means the difference between watching a storm approach on the horizon and suddenly finding themselves inside one with almost no warning at all. While the wind threat was grabbing headlines, forecasters were increasingly focused on a second hazard that tends to sneak up on people: the sheer repetition of the storms themselves. One of the regions drawing the most concern was the Ohio Valley, where the same disturbance track meant that storms were expected to move through the same areas again and again, almost without pause. Schuster described a batch of storms crossing directly over Columbus and Cincinnati during the morning hours, only to be followed by additional rounds of development moving in from the west later the same day. In his words, storms in these areas were essentially going to be nonstop. Later that same morning, a more organized and dangerous line was expected to take shape across Wisconsin and Illinois before spreading and intensifying through the afternoon. That system alone carried the potential for winds ranging from 60 to 85 miles an hour, with the threat expanding steadily to the east and southeast as the hours went on. By evening, forecasters expected that same line to still be pushing eastward, reaching toward Virginia well into the overnight hours. For families in its path, that meant a severe weather threat that didn't end with sunset. It extended into the hours when people are asleep, when warning sirens are hardest to hear, and when the margin for reaction time shrinks dramatically. This is where the pattern becomes genuinely dangerous in a way that a single, isolated, severe weather day is not. A location that takes a direct hit from one round of damaging wind can usually recover. Trees come down, power lines snap, but crews move in, the sun comes out, and the community begins to reset. But when a second round follows within hours, and then a third round follows behind that, the ground has no time to recover. Soil that has already absorbed a first burst of heavy rain becomes saturated. Creeks and streams that were running normally in the morning can be pushing toward their banks by the following afternoon. Drainage systems built to handle a single storm event begin to choke under the weight of storm after storm passing over the same ground. That is exactly the mechanism driving what may be the most underappreciated threat in this entire pattern: flash flooding. Forecasters pointed to what meteorologists call training, a process where a stalled frontal boundary combined with repeated northwest to southeast storm tracks causes thunderstorm after thunderstorm to pass directly over the same communities, one after another, like train cars rolling down the same track. Individually, each storm might drop a modest, manageable amount of rain. But when a dozen of them pass over the same county within a 48-hour window, the cumulative total can overwhelm rivers, storm drains, and low-lying roads that were never designed to handle that volume of water in such a short amount of time. Schuster explained that the danger here isn't necessarily any single storm being unusually intense. It's that the broader atmospheric pattern is steering storm after storm along nearly identical paths, which means rainfall totals can climb rapidly, even as individual thunderstorms continue moving at a normal pace. On paper, that sounds almost mundane compared to 85-mile-an-hour wind gusts or the word tornado. But historically, flash flooding is one of the most consistent killers among all weather-related disasters in the United States, precisely because people underestimate it. A road that was perfectly safe to drive across during the first storm of the day can become a death trap by the third or fourth round, once water levels have crept up beyond what drivers expect. There is a reason flash flooding tends to be misjudged by the public far more often than tornadoes or even damaging straight-line winds. A tornado is visible. It is loud, it is dramatic, and it leaves behind a clearly defined scar on the landscape that television cameras can capture within hours. Flooding, by contrast, often builds quietly, road by road, culvert by culvert, until the moment a driver rounds a familiar curve and finds water where pavement used to be. Emergency management officials have spent years trying to convince the public that 6 inches of fast-moving water can sweep a person off their feet, and that roughly a foot of water is enough to float most passenger vehicles right off the road. In a training pattern where the same corridor of storms passes over the same towns for 2 or 3 days running, those numbers do not need dramatic single storm totals to become dangerous. They simply need time, and this pattern was offering them plenty of it. And this flood threat was not expected to fade quickly. Forecasters warned that the danger would persist through the middle of the week, meaning multiple consecutive days where the same communities across the Midwest and Ohio Valley would need to stay alert, not just to the possibility of severe storms, but to the compounding effects of water that had nowhere left to go. If Tuesday was bad, Wednesday was not expected to offer much relief. Forecasters extended the severe weather risk zone even further, stretching this time from Nebraska all the way east toward Charlotte, North Carolina. Once again, damaging straight-line wind was flagged as the primary hazard, but large hail and the possibility of a few tornadoes were layered on top of that risk, adding yet another variable for communities already dealing with flooding concerns and repeated storm rounds. It was at this point that Schuster used the phrase that captures the entire pattern in a single image: a ring of fire. High pressure, parked stubbornly over the southern plains, was acting almost like a pinball bumper, sending disturbance after disturbance curving around its northern and eastern edge. That circulation created a kind of storm track highway extending through the plains, the Midwest, and the Ohio Valley, a conveyor belt with no obvious off switch. Storms, in his words, were simply going to keep slingshotting around this system, one after another, for days. There's also a psychological dimension to an event like this that rarely makes it into an official forecast discussion, but matters enormously to the people actually living through it. Human beings are generally good at bracing for a single, well-defined threat. Communities across the Midwest know the drill when a tornado watch is issued. Check the radar, identify a safe room, keep a phone charged, and wait for the watch to expire. What people are far less prepared for, psychologically and logistically, is a threat that simply does not end on schedule. When the first line of storms passes and the sky clears, there's a natural instinct to exhale, to assume the danger has moved on. In a ring of fire pattern, that instinct is precisely what forecasters are trying to interrupt, because the next disturbance is very often already organizing somewhere just upstream, following the exact same track as the one before it. There was a second, quieter consequence buried inside this setup that deserves attention. While the Midwest and Ohio Valley braced for repeated rounds of severe thunderstorms and flooding, the same high-pressure system parked over the southern plains was also driving a dangerous buildup of heat across the Great Plains and portions of the southeast. In other words, this was not a story about one hazard hitting one region. It was a story about two completely different weather disasters unfolding at the same time, on opposite sides of the same atmospheric feature, each one being fed by the exact same stalled system. Communities in one half of the country would spend the week sheltering from violent thunderstorms and rising floodwaters, while communities in the other half baked under building oppressive heat with no storms in sight to break it. What truly separates this event from an ordinary summer severe weather stretch, according to Schuster, is not any single day's intensity, but its sheer duration. He said the Midwest could remain locked in this active pattern through roughly August 20th, meaning what began as a 3-day forecast window was, in reality, only the opening chapter of something expected to stretch on for close to 2 weeks. That is an extraordinarily long runway for a severe weather pattern to sustain itself, particularly in a month when the jet stream typically weakens and storm tracks tend to shift northward away from the central United States. Schuster did not mince words about how unusual this timing actually is. This, he said, is not a weather pattern the region has experienced much of over the last 3 or 4 years. By his own estimate, it may have been 4 or 5 years since the Midwest saw a stretch of elevated severe weather risk persist this long during the month of August specifically. For a region that is no stranger to violent spring storms and early summer tornado outbreaks, having this level of sustained risk arrive in the back half of summer, when the season is typically winding down, is what makes meteorologists sit up and take notice. There is also the matter of agriculture, which rarely gets top billing in a severe weather forecast, but sits quietly in the background of every one of these events. Mid-August is a critical stretch for corn and soybean crops across huge portions of the Midwest, a period when plants are especially vulnerable to both wind damage and standing water in low-lying fields. A single violent wind event can flatten a cornfield in minutes, an effect farmers call lodging, where stalks bend or snap and never fully recover before harvest. Repeated rounds of heavy rain saturating the same fields for days at a stretch can drown root systems and invite disease in a way that a single rainstorm typically would not. None of this rises to the drama of a tornado touching down near a populated town, but across a region that produces a significant share of the nation's grain. A prolonged, repeating, severe weather pattern arriving at exactly this point in the growing season carries consequences that extend well beyond any single week's headlines. Forecast models beyond the initial 3-day window continue to show storm activity persisting across the Midwest, the Ohio Valley, and the Central Plains into Thursday and Friday, with no clean break in the pattern visible on the horizon. But it was the transition into the following weekend that began drawing particular attention from forecasters watching the models. Late Friday into Saturday was flagged as a potentially more significant severe weather day, with meteorologists watching Minnesota, Iowa, and Wisconsin closely for the possibility of another serious round involving damaging winds, large hail, and tornadoes together in the same system. Saturday itself could then bring yet another wave across the Great Lakes, the Ohio Valley, and the Central Plains, essentially resetting the entire cycle just as the previous rounds were finally beginning to wind down. By Sunday and into the following Monday, the pattern was expected to begin shifting, with any organized severe weather threat becoming more concentrated toward the East Coast. But forecasters were careful to note that confidence in that longer-range outlook dropped considerably the further out the models were pushed. In practical terms, that means the exact communities that will bear the brunt of the final stretch of this event remain uncertain, even as the broader shape of the pattern prolonged, repeating, and unusually persistent for August, is not in question. It is worth pausing here to understand why duration matters so much more than intensity when it comes to real-world impact. A single catastrophic tornado can devastate a town in minutes and then move on, leaving behind a clearly defined disaster zone that emergency crews can immediately begin working to address. A pattern like this one operates completely differently. It does not deliver one knockout blow. It delivers a slow, grinding sequence of blows spread out over nearly 2 weeks, hitting overlapping regions with wind, hail, flooding, and heat in rotation. Emergency management teams, utility crews, and everyday families do not get the luxury of a clean recovery window between events. Downed trees from Tuesday's storms may still be blocking roads when Wednesday's system arrives. Power crews restoring outages from one round of straight-line winds may find themselves pulled away to respond to flooding from the very next wave moving through. The cumulative strain on infrastructure, on emergency services, and on the people living through it compounds with every additional round, in a way that a single dramatic storm simply does not replicate. It also helps to place this pattern against the backdrop of what has otherwise been a notably quiet Atlantic hurricane season up to this point. Forecasters have spent much of the summer pointing to a strengthening El Niño as the primary reason tropical activity across the Atlantic basin has lagged well behind a typical year. El Niño tends to increase wind shear across the tropical Atlantic, and wind shear is essentially the enemy of any developing tropical system, tearing apart the organized structure that a storm needs to intensify. That is part of why, for long stretches of June and July, the basin produced only a couple of named storms, while forecasters repeatedly revised their seasonal outlooks downward. Against that quiet backdrop, any sign of renewed tropical development in mid-August draws extra attention, not because a single disturbance guarantees a major storm, but because it signals the basin may finally be waking up during what is traditionally the most active stretch of the entire season. And while all of this was unfolding across the interior of the country, something else was beginning to stir far out over open water. Schuster noted that tropical activity in the Atlantic basin was starting to increase at the same time the Midwest and Ohio Valley were dealing with this repeating severe weather pattern. Several separate disturbances were being tracked simultaneously. One system out in the eastern Atlantic was given roughly a 60% chance of developing into an organized tropical system within the following 7 days, a number high enough that forecasters were treating it as a legitimate area of concern rather than a passing blip on the map. A second disturbance, positioned east of the Lesser Antilles, carried a lower chance of development, somewhere around 10%, but was still expected to bring heavier rainfall to the islands in that region around the coming weekend, regardless of whether it organized into a named storm. A third area of interest, located north of Bermuda, carried an even lower probability of development but remained on the list of systems meteorologists were watching closely. Of the three, the eastern Atlantic disturbance was considered the most likely to become a genuine organized tropical cyclone, with forecasters eyeing Thursday or Friday as the window when it could officially strengthen into a named system. Even then, meteorologists cautioned that strong wind shear in the vicinity of the Lesser Antilles could act as a brake on rapid intensification, potentially keeping the system weaker than it might otherwise become in a more favorable environment. Looking further down the model timeline, some forecast guidance nudged the system relatively close to Bermuda by early the following week, while other model solutions curved it harmlessly out into the open Atlantic, away from any populated landmass entirely. That kind of split in the model guidance is common at long range, and it means genuine uncertainty remains about where, or even whether, this system will ultimately matter to anyone on land. Schuster's assessment of the immediate threat to the United States mainland from these tropical disturbances was measured. He said the immediate risk of a major impact appeared low based on current data, but he was careful not to dismiss the systems entirely, offering a simple reminder that carries weight on its own. It is hurricane season. That single phrase does a lot of work. It is a reminder that even when models currently show a system curving safely out to sea, tropical systems have a well-documented history of shifting course, strengthening unexpectedly, or defying earlier projections entirely. Forecasters watch these systems not because today's data guarantees tomorrow's disaster, but because the ocean, this time of year, is primed and waiting, and confidence in any single model run this far out is inherently limited. There is also a broader climate context that meteorologists increasingly weave into conversations about events like this one, even when no single storm can be blamed on a warming atmosphere. A warmer atmosphere holds more moisture, and that additional moisture has to go somewhere once conditions become favorable for storms to form. Scientists studying long-term precipitation trends across the country have repeatedly pointed to an increase in the frequency of extreme short-duration rainfall events, the kind capable of dropping what used to be considered a rare, once-in-a-generation total within just a handful of hours. None of that changes the day-to-day forecasting for this particular pattern. And no single event like this can be attributed cleanly to any one cause. But it does help explain why forecasters increasingly frame flash flooding, rather than wind or hail, as the hazard most likely to catch communities off guard, and why repeating multi-day rainfall events like this one are drawing closer scrutiny than they might have a decade or two ago. Put all of these pieces together, and what emerges is a genuinely complicated, multi-layered picture for the days ahead. In the nation's interior, the Midwest and Ohio Valley are facing a prolonged stretch of repeated severe thunderstorms, damaging straight-line winds capable of reaching into the mid-80s in miles per hour, isolated tornadoes hidden inside fast-moving storm lines, large hail, and a flash flood threat building day after day as storm after storm tracks over already saturated ground. To the south, the same stalled high-pressure system responsible for steering all of that severe weather is simultaneously driving building heat across the Great Plains and into the southeast, creating a second, entirely different kind of hazard playing out in real time alongside the first. And out over the open Atlantic, the hurricane season, which had been unusually quiet for the earlier stretch of summer, is showing its first real signs of stirring, with multiple disturbances now under active observation by forecasters. For the millions of people living across this stretch of the country, the message from meteorologists tracking the pattern has been consistent and direct. This is not a single storm to prepare for and then move past. It is an extended, unusually persistent weather event, one that Schuster himself said the region has not experienced with this level of duration in years, and one that forecasters expect could continue producing rounds of dangerous weather through the end of the week and potentially well into the following weekend. Communities that get hit by one round of severe weather should not assume the danger has passed once the skies clear. Another disturbance is very likely already forming somewhere upstream, riding the same invisible track around that stubborn dome of high pressure, waiting for its turn to slingshot through. There is also the simple, uncomfortable reality that long-range forecasting, even with today's models, is still an exercise in probability rather than certainty. Meteorologists can identify the ingredients, the stalled high pressure, the repeating storm track, the moisture feeding in from the Gulf, and they can say with real confidence that those ingredients favor a prolonged, dangerous pattern. What they cannot do, even now, is tell a specific town on a specific day exactly how strong a specific storm will be when it arrives overhead. That uncertainty is not a failure of the science. It is simply the nature of forecasting something as chaotic as the atmosphere more than a day or two out. It is why meteorologists like Schuster frame their warnings the way they do, less as a single prediction and more as a standing alert. Expect this pattern to keep producing dangerous weather, stay ready to act on short notice, and do not assume that because today was quiet, tomorrow will be too. Whether this pattern ultimately breaks cleanly by the following Monday, drags on even further into the back half of August, or hands off its energy directly to a strengthening tropical system out in the Atlantic remains, for now, an open question. The models diverge the further out forecasters push them, and confidence drops accordingly. What is not in question is the shape of what has already unfolded. A stretch of the country caught inside a ring of fire that refuses to stop turning, storm after storm slingshotting through the same overlapping ground, while out beyond the horizon, the ocean itself begins to answer back.